Good afternoon, my dear students. First of all, I welcome you to my YouTube channel, A.N. Talukdar Maths. Those who yet not subscribe my channel, please subscribe my channel. Through this channel, I will help you and guide you to develop your mathematical skill in the subject. And I am confident that after attending my class, you will get interest in this subject. In the last class, I had discussed about the basic concept of differentiation. That means derivative of a function with respect to x, that is differential coefficient, and what is its geometrical interpretation. So here dy by dx or f dash x is what? Limit h tends to 0 f of x plus h minus fx divided by h. We derived in the last class, derive it, and this dy by dx or f dash x is representing the slope of the tangent at any point on the curve. Okay. Similarly, this is the derivative of a function at any point on the curve, and this is the definition of derivative of a function at a particular point. For example, suppose that this is your graph, and suppose A is a point in the domain. Then if you draw a tangent here, that means if tangent is exist, means f dash a exists. Okay, x can be approaches to a from right, or x can be approaches to a from left. When x is approaches to a from left, and then we can get a left hand derivative, and when x is approaches to a from right, we can get a right hand derivative. So before going to existence of derivative, let us know what is left hand derivative and what is right hand derivative. Okay. Left hand derivative is denoted by symbol LF dash A. Left hand derivative at a particular point, LF dash A, and defined as limit h tends to 0 minus, very important, h tends to 0 minus f of a plus h minus fa divided by h. This is the definition of left hand derivative. And rf dash a is limit h tends to 0 plus, both the expression are same, but just there is a little distinction. One is h tends to 0 minus, another is h tends to 0 plus. This is left hand derivative, this is right hand derivative. If number 1 LF dash a exists, number 2 RF dash a exists, both exist, and number 3 LF dash a is equal to RF dash a. Okay, if it's happened, then we can say that f dash a will be exist. I'm sorry, here equality. Okay, will be exist. The condition is that f dash a will be exist under what condition? Left hand derivative of the point exists, right hand derivative of the point exists, and both are same. Exist means left hand derivative should be fixed and finite, right hand derivative should be fixed and finite, and they are equal. Then you can say f dash a will be exist, means we can get a tangent to a curve at a point x is equal to a in the domain. Okay, this is the actual meaning. Now I hope this is, you understand what is left hand derivative, what is right hand derivative, and how a function exists at a particular point, how f dash a exists. F dash a very important, you remember, f dash a exists means there is a unique tangent at a particular point on the curve. If it's happened like that, suppose that I draw a graph. Suppose this is a graph of a function and it is defined in a suppose closed interval AB. F is a function defined in a closed interval, domain is a closed interval AB. You can consider any point on the curve and you can draw tangent. Here is a tangent, here is a tangent, here is a tangent, or this is a tangent. That means every point there is a unique tangent. Tangent means touch the curve, line touch the curve. But this at that particular point between A and B, whatever be the point, in every point what happen, that is we are getting unique tangent. Okay, unique tangent means dy by dx exists. Dy by dx exists. Now at this point you can draw, this is a tangent. Okay, I can draw this is a tangent, I can draw this is a tangent. All line are touching. That means there are many tangent can be drawn at that particular end point. That means what happen, f dash a has no, f dash a is not fixed. It has different values. No doubt it is finite but not fixed. Therefore you can say at that point f dash a does not exist. F dash a does not exist means the function fx is not differentiable at x is equal to a. Similarly at that point and point the function is not differentiable at x is equal to b. That means in the closed interval AB, in the end point the function is not differentiable, but between a and b at all the point function is differentiable. Function is differentiable. Okay, here we are getting unique tangent. Clear? That means f is differentiable at where? Open interval, excluding the end point. Okay, so this is the existence of that is derivative at a particular point. Let us we solve 1-2 problem, then more clarity will come. You will understand better. Okay, so we start with a very easy and simple problem, and then we solve 2-3 more problems today to complete the chapter. So let us take a question. First question is, check whether f dash 0 exists for fx equal to modulus x. Your function is modulus function. That means modulus function is differentiable at x equal to 0 or not, you are going to check. That means at x equal to 0 whether unique tangent exists or not, that you are going to check. Okay, so and to check the differentiability of a particular function in a point, you have to check left hand derivative at that point and right hand derivative at that point. Okay, so first left hand derivative, L f dash point is 0. Formula is limit h tends to 0 minus, very important, f of 0 plus h minus f0 divided by h. Okay, so limit h tends to 0 minus, your function is what? It is means what? fh, fx equal to modulus of x, fh equal to modulus of h. ये क्या होगा? modulus of h हो जाएगा, and f0 will be modulus of 0, 0 हो जाएगा. This is h, and then limit h tends to 0 minus. Here modulus of h क्या value होगा? This is very important. h tends to 0 minus means what? h is less than 0, implies modulus of h equal to what? Minus h by our definition of modulus function. सो इक्वल माइनस एच बाई एच। कैंसिल करने के बाद क्या होगा, लिमिट एच टेंस टू 0 माइनस 1 and limit of a constant is constant. Now see, left hand derivative is finite and fixed. Left hand derivative is finite and fixed, and hence left hand derivative exists. Now with right hand derivative, let us find right hand derivative. R f dash 0, limit h tends to 0 plus f of 0 plus h minus f0 divided by h. This is your formula. So similarly, this expression and previous problem, this expression in left hand limit, left hand derivative also same. So this result is also modulus of h divided by h. Here h tends to 0 minus 0 plus means h is greater than 0. H is greater than 0 implies modulus of h is equal to h because of the definition of modulus function. So you can write limit h tends to 0 plus h by h, which can be cancelled, and finally you get the answer 1. Now see, your left hand derivative is minus 1 and right hand derivative is plus 1. Both are exist, no doubt, but not equal. Both are exist, but what? Not equal. Since you can say L f dash 0 not equal to R f dash 0, therefore what is your conclusion? Therefore f dash 0 does not exist. That means at x equal to 0 the function is not differentiable. That means at x equal to 0 you cannot get dy by dx or f dash x. That means at x equal to 0 you cannot get a unique tangent. Why? You see, if you go to the graph of modulus function, this is the graph of modulus function, okay? This is your 0. At that point 0, what you will get, you can draw it, and this is a tangent, this is a tangent, many tangent you get, and finally what happen at x equal to 0, you are not your tangent is not unique, and hence f dash 0 does not exist. If I draw another curve, suppose modulus of x minus 1, this is a curve. So how to draw the curve? You make x minus 1 equal to 0, then x is equal to 1. तो वहाँ से शुरू होंगे ये का. It will be shift here. Your graph will be this, and this is x is equal to 1 line. So at that point x is equal to 1 function is not differentiable. If you draw more graph, any graph, suppose x plus 2, modulus of x plus 2, what will be the graph? If you take x plus 2 is equal to 0, उसको 0 करेंगे तो क्या होगा? x is equal to minus 2, तो ग्राफ लेफ्ट में शिफ्ट होगा. This is suppose minus 2, this is the x is equal to minus 2 line. Graph will be like that. Okay, that means at x is equal to minus 2 the function is not differentiable. So all such type of function you can graphically show that the function is not differentiable. Okay, so this is one problem I have discussed. Another problem I am going to discuss, that is called greatest integer function, whether it is derivative exists or not. Okay, question is, check the differentiability of the function fx is equal to box x, which is a greatest integer function. Greatest integer function is what? It is less than equal than x. It is an integer less than equal than, and which is greatest, and domain is 0 less than x less than what? 3 at x is equal to 1 and x is equal to 2. X 1 and 2 are lying in the domain, are inside the domain. So you have to check the differentiability at x is equal to 1 and x is equal to. I am going to check x is equal to 1, you check at x is equal to 2. So to check the differentiability at a particular point, you have to find out the left hand derivative L f dash 1. Formula is limit h tends to 0 minus f of 1 plus h minus 1 f1 divided by h. Okay, so limit h tends to 0 minus, your function is what, box x. ओके, एफ ऑफ 1 प्लस एच क्या होगा, बॉक्स 1 प्लस एच होगा. उसमें देखिए, पुट करके देखिए, एफ ऑफ 1 प्लस एच बॉक्स 1 प्लस एच एंड एफ 1 इक्वल टू बॉक्स 1 एंड बॉक्स 1 बॉक्स 2 बॉक्स 3. उसका क्या होता है, आप लोगों को एक फॉर्मूला मैंने दिया था, बॉक्स x इज इक्वल टू एक्स व्हेन x इज एन इंटीजर. जब x इंटीजर हो जाएगी तो उसका रिजल्ट होता है, बॉक्स 1 का रिजल्ट 1 होगा, बॉक्स 2 का रिजल्ट 2 होगा, तो इट इज़ 1. Here very interesting fact you have to understand. Okay, for box you see, if I draw here number line, your h is less than 0. Very carefully see, h is less than 0. now h is a negative quantity. 1 के साथ अगर नेगेटिव क्वांटिटी ऐड करो, जैसे मैं h का वैल्यू अगर -0.2 ले लूँ तो 1 - 0.2 होगा. ये जो नंबर 1 - 0.2 होगा, दिस नंबर विल बी लेस देन 1 होगा. तो ये नंबर प्लस से आप लोगों को लग रहा है कि ये ग्रेटर देन 1 होगा, ग्रेटर देन 1 नहीं होगा, बिकॉज h इज़ नेगेटिव. व्हेन यू ऐड पॉजिटिव नंबर विथ ए नेगेटिव नंबर तो रिजल्ट छुटा होता है. पॉजिटिव नंबर जो इसके साथ ऐड होता है वो नंबर से छुटा हो जाएगा. सो 1 + h लेस देन 1, 1 + h less than 1, तो definitely 1 + h greater than 0. So here your interval is 1 + h lying between 0 and 1, and you know this is your 0, this is your 1, and this is your 2, or whatever be integer. A box of any number lying between 0 and 1 is result 0. Box of any number lying between 1 and 2 result is 1. Box of any number lying between that is 2. That means greatest integer of any number lying between 0 and 1 is 0. Greatest integer of any number lying between 1 and 2 is 1. Remember this. Since 1 plus is lying between 0 and 1, तो उसका रिजल्ट क्या होगा, 0 हो जाएगी. Now if you put h equal to 0, then it will be undefined. So limit is undefined. Limit is undefined. Now write in derivative r f dash 1. Limit h tends to 0 plus f of 1 plus h minus f1 divided by h, which equal to limit h tends to 0 plus f of 1 plus h क्या होगा, बॉक्स 1 plus h होगा, -1 divided by h. In earlier concept 1 plus h less than 1, here it is different. Very interesting. Here you see h is positive, it tends to 0 means h is positive, here h is not negative. So 1 plus h थोड़ा सा 1 से बड़ा हो जाएगा तो greater than 1 होगा. Okay, so from here what you conclude, 1 plus 1 is less than 1 plus h. 1 is less than what, 1 plus h, less than 2 होगा, because h is a very small quantity. If you add 1 with h, it cannot exceed 2. So go to the number line again, what you will see, you will see this is your number line, this is your 1, this is your 2, and 1 plus h is in between that. Therefore box का box 1 plus h here, तो उसका box क्या होगा, 1 होगा. So limit h tends to 0 plus this is what 1, this is 1 divided by h. And here see 1 minus 1, 0, 0 by anything, whatever be, it is 0. So limit is 0. So left hand derivative is does not exist and right hand derivative is 0. So 1 is does not exist. Then you can conclude that therefore f dash 1 does not exist. That is fx equal to box x is not differentiable at x is equal to 1. Similarly, you can prove that the box x is not differentiable at x is equal to 2. So x is equal to 2 के लिए आप लोगों के लिए होमवर्क है, आप कोशिश करेंगे और मेरे को कॉन्फिडेंट है आप कर पाएंगे. So this is the way you can solve, you can show whether the function is exist, whether the derivative of function is exist or not. So you have to check left hand derivative and right hand derivative, and if they are equal, then you can conclude that the function is differentiable at a particular point. If any one of the condition is not satisfied, then it is not differentiable at this point. So I hope you understand my class, and thank you very much for listening my lecture, and at the same time you concentrate to understand the class. So thank you for your patience. Thank you very much. And in the next video lecture I will come back with a concept where I am going to discuss that a function which is differentiable at a point but not differentiable at a point, then it is automatically continuous at that point. अगर कोई पॉइंट में डिफरेंशियबल है तो कंटिन्यूस होगा, एंड इफ इट इज़ बट रिवर्स इज इफ द फंक्शन इज कंटिन्यूस एट ए पॉइंट, इट मे नॉट बी डिफरेंशियबल. डिफरेंशियबल हो सकता है, नहीं हो सकता है, लेकिन डिफरेंशियबल होने से कंटिन्यूस इज कंपल्सरी. इफ ए फंक्शन इज differentiable at a particular point, then automatically it is continuous at that point. But the converse is not true, and this theorem I will discuss in the next class, and then I will directly enter the basic differentiations, basic formula, whatever you learn in the class 11. I will revise it and start to find the differentiation of particular function by chain rule. Discuss also chain rule. Okay, thank you very much. Thank you.